Start. Okay. So, welcome back to Hackabox. This session, we're actually going to try TryHackMe. It's a bit more of a walkthrough type of their usual boxes. Now, this box that we're going to try today, it's called Wonderland. I think I showed the flag for a second, but it's fine. It's about the process of finding the flag, not just the flag. So this is more of a challenge box. Usually TryHackMe, they have very walkthrough style boxes where they tell you, okay, do the nmap scan. What ports did you find open? What services are running on these ports? Did you find the hidden directory using this word list, for example? Okay. Did you exploit the SQL injection? They will walk you through it. And it's more about, you learning. Occasionally, they will have boxes like these, which are challenge-based. Now, I don't want to expose the flag, but it's two questions, user flag and root flag. That's it. Yeah, obtain the user flag and the root flag. So we're going to start the machine. I should have started that a minute ago, but it's fine. And basically, I'm going to connect through my Kali machine and just start exploring the Wonderland. So let's see. I have to be honest, a bit rusty, and the commands are need a bit of remembering, but we'll make it work. Okay, it fixed itself. Amazing. Do I watch or we do it together? Okay. If you have a TryHackMe account, that would be amazing. It will be very slow. Yeah. خلاص, this type of it's more for the exposure. You see the high level concepts that are happening. What are we doing? Oh, here we're enumerating. Here we are fuzzing. Here we are exploiting and so on. So either way, there's stuff to learn. And what you can do is see this walkthrough, okay? And then after the session, you can do the steps yourself. So you'll try to remember the commands, try to understand them, try to maybe find a better command than what I'm going to run. That's one possibility. That's one very good possibility. But yeah, so I think the machine should be up. We have an IP address. Okay, and let me go to the desktop. Okay, and make a directory. Let's call it Alice. CD into Alice. Okay. Now I want to export IP so I can just have it saved. This is a variable, so whenever I do echo star, sorry, $IP, it's a variable. I can do export. Actually, export is optional, but if you want to pass the variable to any binary you run, this is how to do it. It's too much details. It's just variables. You can actually, let's do the simple example. Let's say name equal Omar. That's a valid command. Echo $sign Omar. Sorry, $sign name, and you get Omar. The $sign is what indicates that it's a variable, not, for example, a string. Because if you just do name, you get the literal string name. Okay, that's good. Now we have an IP. Now I am connected using the VPN. So I need to connect to their VPN. I hope I'm not leaking my personal stuff, but okay. So now we're connected to the TryHackMe network, and we got the IP. So let's try pinging the IP. $IP. Okay, nice. We get a reply back. 64 bytes from the IP. Okay, so there's a reply. That's good. That means we can communicate. First thing, nmap scan. Always. Let's try to run it on all ports. Let's try to make it fast. -T4. And let's scan for, actually, initially, let's not scan for anything. Just make it verbose. And that's it. Okay. We see port 80, port 22. Okay. So when you see port 80, immediately what we think of is, let's just go to the website. HTTP. Okay. Follow the white rabbit. Okay, Curiouser, cried Alice. She was so much surprised that she forgot how to speak good English. Good, good for Alice. Anyways, so follow the white rabbit. That's interesting. Okay. Maybe there's something hidden. No, there is just the main.css. There is a text and then the image. Now the image, if we have time, I'll get back to it. There is a trick they have here. It is not really something you find usually out in the wild, but it's interesting. It's an interesting field of security called steganography. So we can get back to that later. But yeah. So far we're seeing port 80 and port 22. So port 22 is SSH. So yeah, this will take a while, but these are the main ports that we have now. So let's see. I should have opened the thing. That's fine. Okay. Let's run a. Okay. So now we're specifying the. Where is it? Let me get my notes. I honestly never memorize flags. I try to write notes, and then it makes it 100 times faster to find the command I need. So let me search go buster. Okay, I specify the URL. I can also specify the number of threads. Let's do -t 64 threads. I can also specify the word list, of course, /user /share word list. Their buster. These are just word lists like we saw in the CTF prep earlier this morning. It is nothing but possible directories. And I'll start running command, but what we're doing here is go buster, directory searching. Here is the URL, http:// and then just this will replace this IP with the actual IP because this is what we're using here. http dot and then this -t threads -w word list. Let's see what the word list looks like. Oops. Oh yeah, because this is a different shell. Yep, I usually use tmux. You know, it's fine. We'll do it manually. No problem. And it's running. Okay, there's /image. While that finishes, let's see what does a word list usually look like. Let's get the head /user /share word list their buster. This is one that we're doing. Directory medium, for example. That's it. Oh, thank you. The head command for giving the most useless information. But yeah, let's get the tail. Tail just gives you the last, I think by default it's 10 lines from the file. I think you can even specify -n, specify how many, -n100 gives you the last 100. So these are possible directories. These look very weird because at the end of the file you usually have very uncommon directories, but you start with the most common ones like login, like articles, like support /security /category /info. That's very possible /admin and so on. Yeah, index download crack serial. Just possible directories. But let's get back to this. Oh, very interesting. We see we get 3 hits /image /r and /poem. That's probably something to ignore. It's fine. Okay, let's see /poem. Oh, wow. Interesting. A poem. Definitely. There seems to be nothing else, just an actual poem, and they leave it at that. Interesting. Okay, let's see the image. Oh, interesting. We have access to the images. Okay, this is one image. Could this be some hidden message? Possibly, but I'm not gonna go there because I can't read it. Okay, same image, but now it's a PNG. Interesting. And then the white rabbit we saw in the main. So this is just the assets that they have on the website. They have it under image and you can read all of them. Not recommended, but what can I say? Oh, the /r. Okay. /r gives us keep going. Would you tell me, please, which way I ought to go from here? Interesting. Okay. So that seems to be it. But let's try now going to /r and then running the directory listing one more time. Oh, we get /a. Okay, It seems like a rabbit hole. It seems. Keep going. That depends on like just quotes from the book. Okay, /r. Okay, we're getting somewhere. /a/b. Okay, this seems familiar. This seems, there's a pattern here. /r/a/b. Most likely. Can you check the source? Of course. Of course. Let's see. Let's check the source. It's just the text. They have a CSS file. That's a good point. Maybe they actually hide something in one of them, but it's just the CSS, just the HTML. So yes, rabbit, exactly. It seems like this is more of a a CTF style. It's not what you're supposed to see the hackerbox, but this is how they started. But okay. Now, okay, some quotes. Slow, are you walk long enough? Let's feel that this could not be denied. So we try another question. What sort of people live about here? In that direction, the cat stayed going its right to pull around. Blah, blah, blah. In that direction, somewhere here. Both mad. Okay, and then the same image we saw. Let's see the page source, as you said, now because we're getting a different output. And okay, same paragraphs, but what is this? We're getting a paragraph with a display none, exactly, display none. It's hidden. It is hidden. It is there. The data is there, but it's hidden. And it's Alice, some long string. This is usually how we write passwords. When you want to write passwords, you do username, password, when you want to store it in one file, for example. So this is very promising. Now, is it a /admin? Let's see. We don't have a /admin. Okay, there is no /admin. So we should definitely start thinking about what? If it's not on the HTTP, then it must be credentials for, yes, login into what? Let's check the scan. /login/. Now we did try fuzzing, and we did not find that directory. So the credentials are on the website, but they might not actually be for the website. Now, if there's a way to put it in the website, we would. If there's /login/admin, we would definitely try that, but not. There is none. So what we can do is instead try it on the SSH. Because we saw that the SSH is running in port 22. So we should have actually tried the, is there a default credential for SSH? I mean, let's say admin at, is the IP saved? Yeah. Oops. Okay, let me put it into the clipboard so it's easier. Okay, admin. Okay, let's try the default password remake. Maybe they have default credentials, admin. No. So could you check .css? The CSS file, or like a hidden directory called .css? Main.css. Okay, let's see. Font family, background color. It seems fairly, yeah, nothing out of the ordinary. The image, we saw it before. So it doesn't really seem that there's a way to interact with the website, send the data as a post request and get some response. There doesn't seem to be any database involved, no login forms. So our best bet is to try these credentials on exactly Alice at IP. So let's try Alice at the IP. Okay, now let's see that password, which we found here. How do little crocodile? Okay, interesting. Now let's Ctrl+Shift+V, and we get a response. Is it correct? Incorrect. It's taking a long time. And am I even connected at this point? Oh, let's try to stop the scan so it's not overloading the server with requests. And this scan as well. I have too many scans going. Okay, that's interesting. SSH just died. SSH. Oh, it connected. Okay, let's try again. Okay, give it the password. Now I'm not sure why it's taking this long just to get SSH. But we can see, okay, fine. Yeah. Hey, we have SSH. We have a very stable shell on the remote machine. So, okay, wow, there's root.txt, which is very odd. Okay, let's see where we are. Where are we? We are in d/home/alice. Okay, and there is the root flag. It's owned by root, and no one else has any permissions on it. So of course we cannot cat root. We cannot permission limit. Understandable, but also root has a Python file. Walrus and the Carpenters. Okay, so that's interesting and very odd to have it in our directory. So yeah, it's very weird to have a Python file owned by root inside of our home directory. Why would they? And we have read access to it, so that's very odd. So let's see what does it look like. Okay, so it is. Okay, it's a long poem. Okay, import random, and then this very long poem. But we see import random. Okay. For I in range 10, just pick random the choice. Let's try running it. Best way to know what the file is going to do is to run it. Yeah, it's just selected 10 lines. Let me do it again. So, yeah, it just selected 10 lines randomly. It was so kind. Okay, interesting. Oops. So we see that it's owned by root. Okay, and that's a very weird thing to see. But let's try enumerating. Okay, so let's get. I think I have limpys. /lin. Oops, limpys. Where did I have it? Oh, I think slash. No, it was /mount /dev. Nope, definitely not that. See what is in ops. What? Oh yes. I had issues with this virtual machine, so let's actually reinstall it. Let us reinstall limpys. Limpys is an enumeration tool. It's a script, okay, that simply goes through as much as it can, looking for possible exploits or vulnerabilities or misconfigurations that we can use. A quick start. Okay, exactly what we need, a quick start. Without kernel, we actually have access to Python. Oh, actually, this could be very quick because we do have access to Python on that machine. So let's try this installation command. Do we get limpys? Do we even get anything? And that is it. Yeah, I don't think it has access to the internet. So that's fine. We can download it here. Okay, now there's limpys. Beautiful. We have the command here. So we can do secure copy because we do have SSH access. Secure copy this file, limpys, onto Alice at what was the IP? Okay. Colon to specify where we want to store it. So, oops, how do I? Yeah, /limpys.sh. So I'm specifying to save it in the home directory of Alice. let's copy the password, let's paste the password, and we have lenpeas. We have lenpeas. Okay, beautiful. So what I just did is just I copied over the network this file into, because secure copy uses SSH. So I gave it the SSH credentials, the SSH information, and then colon is to specify the path on the remote, which is Alice's computer. So this tilde is for the home directory / lenpeas. That's just the name that I want the file to be. I give it the password, and it is now copied. Oops. And what we need to do now is to add the execution bit to get execution permissions. So now let's try running lenpeas. Oh, interesting. They have very cool ASCII art. But okay. So when you see something that's red or yellow, it's very dangerous, or like something you should definitely look at. So we get some general information. Sudo version. Okay, these are the possible exploits. Now, PwnKit is a famous exploit that I think like demolished sudo, and you can get root access with just a simple script you download. But we're not going to do that because it's not part of this this box. We can even try it, possibly. But yeah, we can get general information. Okay, protections. These are like, yeah, hardware stuff like ASLR. Okay, interesting. Cloud. It tells you that this isn't AWS instance, because it is. TryHackMe the user. Tencent CVM. Never heard of it, but okay. Just getting the instance info. That's cool. I don't know why it stopped. It would be very helpful if it could continue. But actually, you know what? I might actually start my own manual enumeration. Is this the password? Yeah. I might start my own manual enumeration while this finishes. Now let me paste the password here and let me get the IP. I should have used tmux. I should have started with tmux, but it's fine. So I'm just logging in again. So I have 2 sessions basically, because I want to save time. We can keep this running and then we log in. Now, I don't know, something I think is wrong with my own network. TryHackMe is super slow when I try to load the challenges, and even just going through their website. I have no clue why, but we'll work with it. We will work with it. Now, this is, of course, very bad security practices. You should never have your client's password like that in plain text out in the wild. But yeah, let's see. One thing we can try is sudo. Now, let's try sudo-l to see what we can run as sudo as Alice. Okay, so default stuff. And then user Alice may run the following commands on Wonderland. As the user rabbit, we can run /user/bin/python 3.6. You can run this exact file. Interesting. So it's a file written by root, and we, for some reason, as Alice, have access to that file as rabbit to run it. We cannot write to the file, we cannot change the file, but we can run it as rabbit. So I think, how do you get the, yeah, oh, what? How do you, I think it should be here, but this just decided to stop for some reason. Anyway, so, okay, this tells us something interesting. We can run sudo -u to specify the user, rabbit, and then let's copy the exact command. Oh, not rabbit. Definitely not rabbit. Don't try running as rabbit. Okay, so it ran. So now we can edit. Imagine making a case storybook like this. Yeah, that would be a disaster. Is it slow because if we can? Potentially, yes, but also, I don't know, something is off with my own network. I honestly have no clue what's wrong. But yeah, so now we're running this as rabbit. Now, this immediately we don't get any advantages. Just printing the same random line, like the same behavior of the random lines. And that's it. But we saw that we're using the random library. Okay, so this, we need to start asking like, okay, maybe we cannot change the file itself, but potentially we can change what the file is using. Okay, so there's one way to know where Python goes to search for the libraries. So if you do run, oops, I ran it. Okay, that's fine. Yeah, let me just clear it. I don't know why it's copied it. But yeah, Python 3 -c, and -c means just run this command immediately, this line. So import system, and then we want to print, just print to me, what is the system.path, aka where do you look for, where do you search for to find libraries? Okay, slash something.zip, slash reader, slash this, okay, this packages, lib dynamic load, it's a whole different story, this package, okay. These are all specific directories that we do not have access to. And if we go to ls/la/user slash lib slash, for example, Python 3.6, what? How is that? Oh, is that not even a directory? It should be a directory. Yeah, it's a directory. But yeah, we see it's owned by root. Sorry, it's owned by root, and we do not have write access to it. The write bit, the W letter is not available. So of course we do not have any authority over this. These are files, these are libraries that are there that we cannot change. But there's a very important but here. Is this, the first entry is the empty string. Empty string means current directory. And when we think, okay, it's looking first for the current directory, immediately is, okay, we saw that there was, what is it called? There was, let me just do ahead. There was random. Okay, so it's gonna look first in our directory. So let's verify this. Let's verify by nano, let's call it random.py, same library name. Do we need to follow a specific command? Fine. Yeah. So let's see. Print hello 1, 2, 3 with one L. Okay. Now let's, do we still have that command sudo? Yes. Let's see now what is happening. Aha. Interesting. We see hello 1, 2, 3. Trace back, blah, blah, module random has no attribute choice. And that's true because it's now loading our own module and it doesn't have the attribute choice, the function choice. These functions that were used by the program are now removed. We just have a print statement and we see the output. So now we can access our own code and we run it as Rabbit. So that is very powerful. Now, instead of just a simple, instead of a simple statement, let's instead, okay, let's instead run a shell as Rabbit. To run it, we just import the OS module and then .system to run the following command. We're just going to run /bin/bash. We're going to run bash. We're going to have a shell. Now let's write that output. Beautiful. Now let's try to sudo as Rabbit. And who are we? We are Rabbit. Amazing. That is interesting. So all clear so far, like the procedure, the overall procedure. Or would you like me to like repeat a certain step or elaborate more on a certain point? All good, Ali? Amazing, amazing, amazing. Okay, so now we are rabbit. We just have permission, okay, to run the command as rabbit. So let's try the same thing. Sudo dash. Oops, I'm writing on my other. Okay, let's try sudo dash l. Maybe we don't know the password. That's sad. So we cannot run sudo. Let's see. Is there slash home slash rabbit? What do we have here? Oh, interesting. If it's highlighted in red, that means it has the set UID bit set. What does that mean? The set UID bit is basically a way to run a binary, okay, as the owner of that binary. So this binary here is owned by root. Now, the Python script was owned by root, but of course, when we run it using Python as us. So it runs as Alice. Here, T-party is owned by root and has the special S bit. That means it's going to be executed as root. Now, we don't know what the binary is. Let's see, actually, let's read the first couple of lines. Okay, it's a binary. It's a binary. It's not a script, it's not something, but we can see some strings in there, which is very, very interesting. Okay, and let's try running file. Oops, let's try running file. File will tell us what is the type. So it is a set UID bit, okay, 64-bit binary. That's it. It's just a binary. So we don't have the source code or anything. Now, I'll do, is there netcat here? Beautiful. Beautiful indeed. Okay, now this is a different disaster. I don't know why it's not running. But let's try, let's see. Okay. So we have rabbit, we have access to rabbit. Let's see what, get a general overview of what we have right now. So we have this binary that we can run as root. Let's actually try running it first. Tea party. Welcome to the tea party. The Mad Hatter will be here soon, probably by Saturday, 24 February. Okay, so it's using probably the date command to get this date output. Ask very nicely, and I will give you some tea while you wait for him. Give tea. It says segmentation fault core dumped. Now, segmentation fault core dumped is the error you get usually when you're accessing memory that you should not be accessing. Now, usually when you see a binary in a CTF challenge or a hack the box challenge and it gives you this, 99% of the time, it is a buffer overflow, which is a type of exploit where they're using a vulnerable function, a very bad function which should not be used to take end user input. And when you use it, you can actually you can change the program's behavior solely using your input. So you give it a certain input that will change its behavior, and you can tell it, go to that function, run this, run that, and it's a whole field of binary exploitation and so on. But something is fishy here. Like, even if I give it nothing, it tells me segmentation fault, which is weird. Like, usually when you give it a big input, so you give it too much, you cannot handle it, and it starts behaving randomly. But here, even if I give it just one, it prints segmentation fault. So that's weird. Now, I want to, let's see. Okay. I want to actually do something extra that's hopefully be interesting. P 1 2 3 4 into what is it called? T. Okay. I want to netcat onto my own IP 10.8.77. I'll explain what I'm doing. Oops. 77.216 port 1234 and feed into that this T-party binary. Did this work? Ooh, we got a connection. So what I'm trying to do is I'm listening, okay, on some random port 1, 2, 3, 4, and whatever you listen, okay, I'm telling it put it into the file called T, and here I'm telling it connect to me, my attacker machine, port 1, 2, 3, 4, and feed into that command, okay, using this arrow, the T-party binary. So now here I should have, let's check the MD5 sum of the T. Okay, to make sure that the sum is basically a short string that summarizes the whole file. It's as simple as that. You give it, no matter how big of a file or a string you give it, a hashing function will give you a short random representation, but it's, if you give it the same input, you get the same output. And so you use it to verify a file. So make sure that nothing changed in the file where you were transporting that file. So if you do MD5 sum on T-party, let's just verify the first three. 8ED 957, 8ED 957, beautiful. So we know that we're getting the exact file. Now I'm going to do something sort of, oh, I have it in the up directory. Let's just move it from here to slash home curly desktop as. Okay. I want to take this. Now I'm just exporting it back into my machine because I want to show you Ghidra, I don't know how to pronounce it. It's a reverse engineering tool made by the NSA. It's an open source tool, and it's used for reverse engineering. What is reverse engineering? It is basically getting some binary and trying to take it back into the C code or the original code programming language it was written in. Because the binary is basically unreadable, it's just assembly instructions, and that is too much to read. But import file, let me do it here. Desktop, documents, shared, okay, imported, it's being imported. Analyze it, please analyze it. Now it runs so many algorithms. It tries to go back from that assembly instructions, okay, those ones and zeros, goes back to normal assembly instructions if you've seen them, like move, AX, BX, these type of instructions, and then takes it back to C code, and it has to guess. That's the thing. The decompilation, okay, the reverse engineering, it is never going to be a perfect match of the original source code. So, oops, no. Yeah, so these are the assembly instructions. Push RBP. Now this is a whole different, this needs like a series on its own. But we see here functions, okay, some functions, and then we see the main function. It's always better to start from the main function to know what the program is doing. So the main function, this is the assembly, we don't care. We want to see the decompiled, how it thinks the source code is. So there is some set UID and set GID happening. Okay, and then put S. Put S just means print, put string. So just like the print in Python, welcome to the T-party, this is what we saw. And then system. System means run the command as, just run the command, run the system command. Just like we were doing grep, we were doing bin bash, we're doing everything here is doing bin bash, sorry, bin echo, /n, this, and then this, okay, string, and then and, so another command, date, the date command, the next hour, okay, whatever the formatting is, don't care. But you notice here it's using the exact path. It's starting from the root directory /bin/echo. You can never go wrong with this, you know, that's the exact path. Only the privileged users have access to this, not us. So we cannot change this. But here, it's doing something weird. It's running the date command that is supposedly the date command. But who said date will always resolve to /bin/date or /user, whatever it is stored at? It is this, basically, when you run a command, when you go to run a command, what happens is, let's say I want to run the date command. Okay, I get the date, but I want to tell it which date. Okay, /user/bin/date. Why so? Because there is a special variable called the path variable that tells it, okay, if you were looking for a binary to run, of course, the current directory. If not, look the user/local/sbin. That's the first one. If not, /user/local/bin. If not, this. If not, that. If not that. If not that. So this is the first one. So here it matched /user/bin here. Whereas, yeah, it matched it here. That's why we don't need to do /user/bin/date. It will still work. It's the same thing. But here, it's just for simplicity. But it becomes an issue when you can change the path variable. This is when it becomes dangerous. So what we can do is, let's try to create our own date. Okay, enable to create directory. What? Where are we? Oh. Okay, that's fine. We don't care about that. Nano/date. So we're gonna do /bin/bash for just formalities, and then let's say we're gonna change it to just echo 1, 2, 3, 4, 5. We're gonna create our own date binary. It's now just a shell script that is going to run the echo command. Okay. So of course we can run it, but also let's try running tparty now. Will it run that one? No, it ran the same date command. And this is the correct date. Weird. Let's see the path variable. Where is it going? Oh, it's going to these. So if I just write, yeah, see? It worked when I did it locally. I forced it to look into my directory. But when I just do date, it defaulted to this. Let me ask it, which date are you talking about? It's talking about the bin/date. So it found this /bin/date here. So what we can do is export the path to be equal to this directory. So look into my directory first, and then colon whatever rest of the path variable is, because we don't want to break it. So I'm just adding I'm following the notation here. It's a directory colon notation, the colon directory, and then so on. So here I'm adding the home/rabbit, and then colon the rest of the path. So now if I look at the path, now it's /home/rabbit first, and then this, and then this, and then bin is still here, but it's now at the end. So see, now if I just do the date command without the /, without forcing it or anything, the first place it will look at is /home/rabbit. So now it's going directly to my binary, which is amazing. So now let's try doing tparty. Probably by 1, 2, 3, 4, 5. So now we changed how the binary behaves. Even though we did not change the instructions, we did not change the source code of the binary that was used to create the binary, but we changed the behavior by changing a dependency. So now let's actually make a useful date binary. And oops, oh yeah, because it's on the SSH. Just /bin/bash. As simple as that. We don't need anything else. If you can give us that, that's amazing. And we are Hatter. Beautiful stuff. So, okay, we are now Hatter. Of course, can we run /l? Nope, cannot. Yeah, sorry, try again. Okay, let's see /home/Hatter. Ooh, password.txt. Now let's actually go to that directory, see maybe something else is there. I'm gonna cut out that password.txt. Why is a raven like a writing desktop? Who created this file? Interesting. So now we have the password. So now let's try So this is in their directory, so we're gonna assume it's their password. If not, we're gonna try other users. Why not? But let's try sudo -l. Okay. It's not an incorrect password, but user hatter may not run sudo on Wonderland, and that's fine. Now let's run that same lenpiece enumeration script. So I'm going to send it here by listening on port 1234 len.sh, and oops, what's this? Okay, never mind. Yeah. Now I have litcat. I keep forgetting the IP. It's 10.10.58.56. Okay, port 1234, and please send to it the lenpiece binary. Okay, connection received. Amazing. So let's give it some time. This is not the most secure or most. Yes, it did. Yes, we got a shell as hatter, and then sudo. Even if you have a shell, you still need to give the password to run sudo. So we gave it the password, which we found as a txt file, but it was correct. But hatter cannot run anything as sudo on the machine. So it's fairly useless for now, at least. So now we have the lenpiece binary. We're going to make it executable, and we're going to run it. I hope it does not get stuck like last time. But yeah, we are hatter. We are in the rabbit group. Oh, interesting. Oh yeah, this is it's telling me this is a very dangerous thing to have to be able to change the path. That's a different story. You should not be able to change the path variable. But interesting, date and uptime. Is it that difficult to get the date and uptime? And let's give it some time. Yeah, I have no clue why it's acting like this. Well, anyways, we can perform our own enumeration. So let's see. This is the hatter live directory. Okay. Let's maybe look for files with the set UID bit set, maybe. Okay, let's see. So let's see. We're gonna find in the common places /user /bin /sbin /user /sbin, for example. We're gonna look for files with the permission 4000. Okay, that means now this is a short notation using the octal base 8 to or define permissions. So forget 000, but 4, the first one here, it will be in binary. It will be from right to left, 001, right? Yeah. So basically, that is looking for files or binaries which have the set UID permission set. Now, what is this permission? This is the one that we saw in the Tea Party. It's the Tea Party binary. That means you run it as whoever owns that file. Okay. So this, what am I writing? Yeah, this command is looking for binaries that I can run as different users, basically. Okay. And now this is just boilerplate stuff. This is oh, did not find anything in those directories. It found nothing. Okay, because the one that was there, it was in the slash home slash rabbit. Like if we go home, was it there? Maybe we don't have access to it as the Hatter, but it's fine. So there's nothing like that again. So they're not going to give us the same trick twice. Fair enough. There's also not just the bit on the file itself, but there's something in Linux called capabilities. Capabilities, they extend the functionality of the set of the permissions that we have on files. So instead of giving someone root access on everything and with every capability, you can make it more granular and you give them specific capabilities as the root user. So let's look, maybe find something. Okay, interesting. Okay, what is this command that I just ran? I'm getting the capabilities in the following directories: /user/bin, typical where the binaries are, and /bin. And then 2 goes into /div/null. You'll see this a lot. Basically, I'm telling it, don't give me errors. I don't care. If you find permission denied, if you find something useless, see, yeah, here there's no errors. You usually find this when you're running the find command. If you find /name, I don't know, ABC maybe. Yeah, see, all of these permission denied. How do I get rid of them? I go to, goes into /div/null. So 2 is the file descriptor for the standard error. So errors go to the null. /div/null is a binary that does nothing. So I'm telling it, any errors, forward them to that binary. That binary will do nothing. It will not print them. It will not do anything. And it will keep the terminal clean. It's as simple as that. But yeah, let's get back to our command. Get capability. Okay. So we're looking for capabilities on files in these directories. We find mtr packet, find Perl, and net raw. Okay, this has to do with networking. That's fine. That's typical. But it's never the case you find the setuid capability on the Perl binary. That is very, very, very unusual. So let's see. Yeah, it's owned by root. And it's in the Hatter group. So we're part of that group. So we can execute it. And it has the setuid capability. So what this means is that we can actually run it as root. So let's see how we can go about to actually exploit this. Okay. There is a popular website, okay, and it is called GTFO bins. Why did they call it that? I have no clue. But basically, it's on GitHub. It's a GitHub website, website. It's a very idea of it is very simple. It has a lot of binaries that you can find on a typical Linux machine, and if it tells you the possibilities for exploitation, given that binary has, for example, suid, it has sudo set, just like we did with the Python file that had sudo, and just like we had the suid bit on that binary, but those were for specific, homemade files. But this is for the more famous files and for more famous binaries. So here we find Perl, okay, and it tells you the functions. Shell, not interested. Reverse shell, not interested. File read, no. Capabilities, okay. It tells you if the binary has the Linux cap setuid capability set, or it is executed by another binary, the capability set, that's a different story. It can be used as a backdoor to maintain privileged access by manipulating its own process UID. That's his fancy Linux lingo, but whatever. The main idea is basically we have access to this binary, and it has a capability set for us, which is a setuid which means we can run it as the root user. And that's all that matters. Is that clear? The idea of what we're trying to exploit here. It's a misconfiguration. They set a capability, they give us a capability that they should not have given us. So, okay, this is part of like setting up the exploit. I think this is all that we need. Let me try. So, I am not familiar with Perl. Perl is an interpreted language, just like Python. You know, we do Python import system dot open os.system and then /bin/bash, the one we did for the random.py module. This is basically the same thing but in Perl, but it's a different language. So they use POSIX setuid and then they execute /bin/sh. So it's doing the same thing that we did with the random.py module, but here it's doing it in Perl. So let's try. Permission denied. Okay. Maybe I need to run this first. No. I mean, we can try that, but I think I have an idea why it's not working. Let's see. I think we don't get the capability unless we log in as the user, because here we just get a shell by exploiting that other binary. So let's try the same thing, but now SSH, because this is unusual, because we have the capability. Why is it not working? Must be something that we're not doing. So let's try to get a normal SSH. You can never go wrong with SSH. It's as simple as it gets. So we're going into Hatter. Okay. Now let's try running that same command again. Hopefully now I have the capability to get something. Oh, interesting. We get the hash symbol. When you run bin/sh and you get the hash symbol, that's usually a good sign. Who am I? I am root. That's why it's a good sign. The hash symbol in the bin/sh is just their way of telling you you are root. So we can now, it's not a stable shell, it's an annoying shell, but okay, cat user.txt. Oh, nice, found the flag. Also, we remember seeing in the in Alice's directory, if we go to cd /home/Alice, there was the root.txt. It was not in the root directory, which is very unusual. You have the user text under the root, and you have the root, the text under the normal user. So it's a weird way, but yeah, here's the other flag as well. You can submit this, and these are the correct flags. But so that's it. We have the root. There's nothing more that we can do. Let's go through, like, let me just summarize what we actually did. Okay. We started on the box as Alice. Oops, that font is too big. And you need to excuse my handwriting, please. So we started on the box as Alice by getting, actually, way before that, we had the HTTP. Okay, under HTTP, we followed the rabbit hole by going /r/a/ until we went to /rabbit. Okay, under that we found SSH for Alice. Beautiful. After we get SSH as Alice, we looked around, we found that there was a Python file. So under Alice, we found a Python script that we could run as the rabbit user. So what we did, we created our own malicious random.py. Sorry for that amazing handwriting. So we made our own malicious random.py. We ran it. We ran that file as rabbit, and we were able to become, well, rabbit, the rabbit user. Under the rabbit user, oops, there was, oh, that's a very big screen. Okay, under the rabbit user, there was the T-party binary. Now that binary had what people call setuid or the sticky bit. Basically, you run it as whoever owns that file. So we found that it was using the date binary using a relative path, not using an exact absolute path. So that was very dangerous. So what we did is we created our own malicious date binary, or actually shell script in our case, but it didn't matter because it was still going to run it. And what did we get from that? We got Hatter. So the date binary, our own malicious date binary, give us access to the user Hatter. Okay, beautiful. Now, one issue with Hatter is that capabilities, similar to the setuid, and it's a whole topic to get into the Linux capability. It's very interesting. The capability for the setuid capability setuid, which was on Perl. So we read online under GTFO bins. Okay. How to write a command that utilizes this capability in order to run it as whoever owns it. Perl is owned by the amazing root user. Nothing higher than this. So we run the Perl command using git capability, and we become root. We get both files, and that's basically the machine done. And that's it. So is the overall concept clear? The flow that we had? Zoom out, of course. Yep. Is this good? We started from HTTP. We went down the rabbit hole. We found the SSH credentials. We SSH as Alice. We found that it was running. We could run as sudo. So we can run sudo as rabbit, the Python file, only that file, not any file. It said the command that you can run is /python, like whatever, Python, and then that exact file. So you cannot run any file as rabbit, only that file. But we found that that file is loading the random library, and it's using it from the current directory. So immediately we just create our own random.py in the current directory to get a shell as rabbit. Similar issue, the T-party is using the date command without the exact path. So we can just create our own malicious shell script, which is going to give us access as Hatter, because he's the one who owns the T-party file. And then finally, Hatter has the capability of the setuid capability on Perl, on the Perl binary, which is a programming language. And it has an interpreter, just like you can run Python commands in the terminal, you can do the same with Perl. So who owns Perl? Root. So we go to the GTFO bins website, we find the command, we run the Perl command, which gives us a shell, and that shell is going to be as root, and that is the end of the box. There's nothing further to do. We get the flags and we leave. Okay, amazing. Any questions, inquiries, anything not clear? All good? The flag, yes. Here they are. This is the user flag, and this is the root flag. We found the user flag under the root directory for some reason. and then we found the root flag in the beginning. We actually found this under Alice's directory, which is the first person we got control over. Just curious. Yes, no, that's fine. It's curiouser and curiouser. The flag itself is curious, and Alice is curious. But yeah, that is basically it. Any questions? All good. Amazing. Well, thank you so much, and inshallah see you next week.